What is it about cycling that most modern people don't get? I'm not just talking about too few people using bicycles, because that would be crazy. What is it about cycling that most modern people don't get? I'm not just talking about too few people using bicycles to get around. It's as if the majority of the world's people are stuck on a mental conveyor belt, gradually and inexorably moving toward oblivion. As if the knowledge of our own mortality, our only real cradle-to-grave experience, somehow gets fused with our naive understandings of entropy and a rather impoverished view of eschatological religious dogma, and altogether makes us think everything is linear and that we're facing the end of times. It makes for great apocalyptic fiction, but it's a mental model that just happens to be wrong. Some scholars, my postmodernist graduate school professor Ed Soja at UCLA was one of them, particularly through his book Third Space, thought Some scholars, my postmodern graduate school professor Ed Soja at UCLA was one of them, particularly through his book Third Space, thought the invention of Western writing had a lot to do with it. Have you ever seen the 2016 movie sci-fi linguistics drama Arrival, or read the award-winning novella Story of Your Life by Ted Chiang, upon which the film is based? One of the key points in that story is that the octopod extraterrestrials who arrive on Earth write in imbricated inkjet circles that script out like vector-based Prezi diagrams. Their sophisticated form of written language, unlike our primitive linear grammatical and syntactic symbols, contains such complexity and spiral connectedness that it enables simultaneous thought of past, present, and future, and makes the nonlinearity of the T portion of our space-time continuum obvious to all readers. In other words, just by glancing at their text, one can see how time flows forwards and backwards, just as the other dimensions of space do, just as Einstein suggested it does. We humans, at least we modern Western literate humans, have a hard time grasping nonlinear systems. Professor Soja argued that because we have been trained since kindergarten to think in a straight-jacketed way from left to right, beginning to end, from once upon a time, forgetting that in the multiverse it doesn't have to be just once, to and then they all died, or they all lived happily ever after, always and ever after, as though causality always marched in one direction, that time is linear. And so you may be asking yourself, just as Einstein suggested it does. We humans, at least we modern Western literate humans, have a hard time grasping nonlinear systems. Professor Soja argued that because we've been trained since kindergarten to think in a straitjacketed way, from left to right, from beginning to end, from once upon a time, forgetting that in the multiverse it doesn't have to be just once, to then and they all died happily after, we humans, at least we modern Western literate humans, have a hard time grasping nonlinear systems. Basically because we've been trained since kindergarten to think in a straight-jacketed way, from left to right, from beginning to end, from once upon a time, forgetting that in the multiverse it didn't have to be just once, to and then they all died, and they all lived happily ever after. It's always and ever after, as though causality always marched in one direction. So you're asking yourself maybe, what does this have to do with waste? Or are you just wasting my time with these philosophical meanderings? No. It turns out that linear thinking, devoid of the ability to meander and cross-cut and jump around and take a bird's eye view, is at the heart of our waste problem. But that hamstringing orthogonal way of thinking can be defeated, turned around and around and around. But first, we have to unpack our biases. But first, we have to unpack our biases. For a second, let's look at the periodic table, which has been accompanying us throughout our journey in this nonlinear course. Chances are you were taught it all wrong. Do you know why it's called the periodic table? Because it's meant to be read in a circular fashion, not in a linear fashion. It turns out the properties of the elements are cyclical. And once you know that, exciting predictions can be made of how to reconstitute matter and combine and recycle the elements. The limitations of the printing press and two-dimensional paper and a lack of imagination among school teachers made that almost impossible to grasp without explanation. I only learned it myself when I found a big vinyl periodic table at a school I taught in and had the audacity to wrap it around me like a dress. All of a sudden, it became clear, for example, why carbon and silicon and germanium are so similar, and why they can be used, for example, to make solar cells and semiconductors and nanocomputers, and why you never want to throw anything away. This is one of the shifts in nexus thinking we talk about in our Navigating the Food, Energy, Water Nexus class, and it's necessary to rethink waste in the same way. To get to our desired circular economy, we need to see all the circles and find tools to literally take the straitjacket off of our thinking. For example, if you've been going through this course in Canvas according to the left to right, top down sequence, you may think that this is the last module of the course. And if that's the case, and you're getting to this module last, you may have indeed been forced into linear thinking by the very medium Professor Ed Soja talked about. This module is about cycles in nature, biogeochemical cycles, carbon and nitrogen and phosphorus cycles, among others, a type of recycling that's been going on for billions of years, a process that's ensured that life is sustained and thrives on this spinning round planet. Yes, the world is round and spherical. Sorry, flat earthers. And because the Earth is a spinning ball powered by the sun with a molten core, and because gravity is real and makes dense objects fall and less dense objects and materials like water vapor and heat and helium and hydrogen rise, we have spiral cycles that move things all over the planet, creating cyclones and typhoons and hurricanes and weather systems and climate changes and movement of materials and massive gyroscopic concentrations of plastic like the Pacific Ocean garbage patch, and the accumulation of radioactive isotopes in Antarctica. No place on Earth is free from our effects, from the things we waste. But by the same token, relative to our time on Earth, nothing will ever run out. And life doesn't end with our personal passing or the collapse of our fragile civilizations. We live on a circular, recycling planet, and we need to talk about these bigger truths and cycles, but we need to talk about them in non-linear ways. This could very well be the first module of this course. No matter where you start, you'll always end up coming back to the same point. There's no such thing as waste. Now how's that for circular reasoning?